All right, so welcome back to another JNCISP video. This is the topic device infrastructure, high availability, aggregated Ethernet, including fault detection, which I take to mean OAM, because OAM is a big part of what a service provider does. So it's got to be somewhere on the test, I'm sure, but I don't see it falling into any other topic, and fault detection is part of what OAM can do. So I'll just take this as the opportunity to practice that a bit. So where I had left off before, I was trying to get connectivity or I was trying to advertise an ISIS route over a link, over two links between R2 and R3, but I had trouble with that. I couldn't get the route to, so I couldn't get the router 3 to be in the same ISIS database as is on router 1 and router 2. I have two separate databases, one where only router 3 is in it, and then another one that's the same on router 1 and router 2, where both of those devices are a part of it. But I can't get a single database across all three routers with all three routers in the database. That I'm having trouble with. So I'm going to do a few minor things to try to see if I can accomplish that. The first thing I'm going to do is just shut down one of the aggregated Ethernet links. Maybe that will help it. Oh, and it looks like I'm getting the classic error where I lost the command prompt. Yep, so I'll need to do a reboot. Let me try reopening GNS3, maybe that'll do it. So this had been pretty rare, but now it's starting to become a lot more common for some reason. Really wish I knew more about what is happening when it does this. But let's just reboot the server and we'll have a little bit of extra time while that's happening. And I think I'll read a little bit more about ISIS databases, do some Google searches, and maybe it will make sense why there are those two databases for this topology of three routers and not a single database. All right, so the way I like to restart, and I'm sure I could just hit the restart button here, but I'll just do it in the console. I think it might be a little bit cleaner of a reboot. I don't know if just hitting that reboot button has the same effect as using the menu here to hit reboot. And I know that this works. I've done this many times before, so I will do it again. And while it's booting up, I'll be doing some Google searches for ISIS database. All right, and now hopefully we can figure out. So here we go. This looks good, an ISIS tutorial. So let's see if there's anything talking about database. So here's the link state database. So, so here's information about level 1 versus level 2 interfaces. And some best practices. Oh, you know what? Maybe this is it, the ignore attached bit. So the attached bit is set when a level 1, level 2 IS learns level 1 routes from other level 1 routes in the same area. That must be it. This attached bit causes the installation of an ISIS learned default route, as well as which in the, okay, well, maybe we could try that. I do remember something about the attached bit and it causing problems. Let's just try that. Once the routers are back up, we're gonna try setting ignore attached bits on routers 2 and router 3 at least. I don't think we'll need to do it on router 1, but hopefully that will be the key. So it's got to go through the boot up process, which takes quite a long time on Juniper VMX routers. Hopefully not too long. Oh, it's kind of taking too long. Keep looking through this. Yeah, I wish I knew more about what was going on here, because I'm not sure why this unblocking device takes so long. I did do a lot of searching on this earlier. Yeah, when I first got this lab going to see how I could make this faster. Ah, there we go. So usually it just takes a while. Yeah, so loading the chassis module. All right, show configuration, pipe display set, pipe no more. So let's start off by adding that ignore attached. So edit protocols ISIS, and this is going to be a knob. So ignore attached bits. And we'll add it to router 2 as well. Let's do a show route protocol ISIS. We'll do a pipe refresh. Oops. Okay, and then we'll add it to the other side and hopefully it will populate. All right, so it's still not populating. One thing I want to try is shutting down one of the port channels. Perfect. So let's see if the route is being learned now. So nope, it's not being learned. Yeah, I'm really not sure why the route isn't being learned. Let's look inside of the ISIS protocols and see what the missing piece is. Now, as I've mentioned many times before, I have not gotten through the ISIS topic yet. That is coming up later. So I do want to, I think, perhaps move on and not spend too much time on this topic, since I will be spending ample time later, and I want to get through the topic about aggregated Ethernet, links, and OAM. And this is going to be the last video on that topic, so I don't want to spend too much time in this video shooting something that's not related to that. So let's actually kind of put that into action and move on now. Unfortunately, it's just, oh, what's this? Delete. Oh, that would be disabling ISIS. ISIS is enabled right now. I guess it's just, let's see, set traffic engineering. And then IGP topology. All right, so yeah, I'm not sure why it's not learning it, but this will be a good primer for when we go on and actually learn about ISIS. This will be hopefully a question we can walk away from having an answer once we go there. But let's not waste all our time working on that now, since we're going to be working on it later. So let's just strip down the topology to the bare minimums and work on OAM. So we will use some port channels just because that's also going to be a part of it, but it's just going to be real simple port channels, just one, and we'll just have a we'll just have two links in each port channel that we use. So let's get rid of all of the existing links just so that everything is kind of set up from square one, and we'll even go ahead and reconfigure all of the devices back to their default config that I start most labs with. Okay, so yeah, let's strip down the configure those devices and then wire them back up, and then put on some basic config, and then explore a little bit of OAM, and that will be the last video on this topic. And then we'll move on to the next one. So we can see we're going to need to roll back. We'll roll back to commit number 2. Yep, because we did have a commit, and that was to give it the initial config. So let's make sure that went good. Yep, everything looks great. Oops, lots of commits on this one. Let's roll back to commit 24. And another, I've said this in many other videos, but Juniper unfortunately does not have the capability that I know of, maybe it does, of rolling back a single commit. When you roll back commit, for example, I'm doing 24, you also roll back every single commit that came before. That's a really important thing to know, especially if you're used to working on iOS XE, because in that case, you do have that capability. So I rolled back every single configuration change up to and including the configuration change that happened with the 24th commit. And then the 0th, this is the running config. All right, so same thing on this one, but it's going to be the 27th. All right, so we'll verify this one. Perfect, and now we will, let me do a show license because I wonder if, okay, so, okay, yep, I do have my license added on there. So I get some special features. I get enhanced bandwidth and I get premium features. So yep. So I just wondered if maybe the reason I was losing the CLI prompt was because I didn't have my license. I wondered if some of those GNS bugs were less persistent if you had a license in or not. All right, but let's wire up the topology before configuring anything. So we're gonna have port channels between everything, just to keep practicing that. And then we're not going to use any help documentation. We're not going to use any help documentation for this exercise that we would not have during the test. So if I get stumped, what I'm going to do is a help apropos for the thing I'm being stumped on. For example, 802.3AD, how to configure a port channel, and then I'll get back help reference, help topic, and I'll look at that until it triggers my memory into what I need to configure. But I believe I understand well enough how this is done. So it's going to be edit chassis aggregated devices, Ethernet, and then set device count. And we just need one. And then I'm not sure if you need to set LACP. Let's try setting LACP link protection as well. Well, actually, let's just start by getting the port channel to come up, just a basic configuration without any extra bells and whistles. Okay, so now I've got to go over to the interfaces I want included in the port channel, the physical interfaces, not the logical unit. And here it's going to be set, and then it's, yeah, gig ether options. It would be different depending on the type of interface, but we have gigabit Ethernet interfaces, so it's going to be gig ether options. You can see the other kinds of interfaces you can have. So here's gig ether options. It's also got optics options, OTN options, options for just about any other kind of interface you can think of. I guess I don't see any for a fast Ethernet interface, but But yeah, in our case, we're going to be using gig ether options, and this is going to be 802.3 AD, and it's going to be belonging to AE0. Yep, and then now this is how I thought you enabled LACP, but okay, this is the bare bones. As I said, we're going to go with the bare bones configuration. So let's set that up for the other interface in that link. Perfect, and now it's time to configure the IP address, just the basic connection information. All right, so that looks pretty good. Yep, and that's, I think, all we're going to need for now. We will need some sort of dynamic routing protocol, some sort of IGP, or we can, of course, just use static routes. But for now, I'm just going to commit this and then move on to the next router. So on this router, we're going to need 2 Ethernet appliances. Okay, and then 000 and 001 are going to be belonging to AE0. Okay, so we're off to the right start. So let's complete that thought by putting a description on the port channel going to R1. And an IP address. Oh. I was just on a Cisco earlier. It's kind of nice in some sense how like simpler some of the things are in Cisco. Instead of family INET address, you get IP address. But at the same time, that kind of extra verbiage in Juniper can be a little bit nice too, because it's more like clear what the that is different address families, and if you're configuring ISIS, it's going to be family ISO. And I kind of sometimes like a little bit of extra jargon to help me remember what needs to be configured, but it's always nice to have things nice and clear and in plain language and not in jargon form. It's always, I think, more convenient, but sometimes it's just not as useful. All right, so let's see here. Address. All right, so same thing on here regarding setting up the aggregated Ethernet device. Here we're only going to need one though. And here we decided to go with GE 2 and 3. Perfect. So everything is ready to go in order to configure that AE0 interface with a description and IP. All right, so let's verify that the AE interfaces are all up, and they are. Yep, that's up too. So we see that this one's up. I'll just do it just because it feels nice to do them all, to just see that they're all up. All right, so now we've got the IP addresses going good. We're going to need some kind of IGP. We can of course just do static routes, but let's keep it easy and just use OSPF. Oops, so okay, I filtered it out based on AE0. So I didn't check AE1. AE1 is up though, thankfully, but I will need to enable OSPF on both AE0 and AE1. Oops, AE0. All right. Okay, so hopefully we've got full routes, show route protocol OSPF, pipe refresh 1. Sometimes it takes some time for the adjacency to come up and for the routes to be advertised. Let's take a look at the neighborship on router 2 so we can see both at the same time and make sure that they come up. So it looks like they're getting there. There's one that's in full, but there's another one that's in Xstart. So let's see if we can get information just from the help apropos on Xstart. Nope, nothing matches. Well, let's see what we can get for OSPF. Okay, so we can get a bunch of things. Let's see what we've got for help topic. Okay, so we've got all sorts of things. So maybe if there's one for neighborships. Let's filter it down to help topic OSPF. Oh, and let's include a space so we don't get help on OSPF 3. Okay, so here's all the help we can get. We can get interface topology, peer interfaces, all sorts of stuff. But let's look at, instead of help topic, let's look at help reference. Okay, so now we get interface. So what I want to find though is help on the xstart adjacencies. So I think this might be a good place to start. So let's take a look at this. So, and let's do a match for xstart. Oops, and we got nothing. Another thing we can do if we've got CLI or start shell, and we can get a Python, we can't. But if we could get a Python terminal and do some scripting, we could search through all of the available documentation and just look for xstart. So huge advantage to having a Python shell built into the box. I know that you can get that with the modern Cisco OS images, and you can also get that on Arista. So unfortunately, I don't see a way to do that on Juniper. If I could learn how to do that, that would be a huge advantage during the actual test, because I could just search through all the documentation available for anything and jog my memory. So Python shell on Juniper. I think there might be a way to do this. So I know you can do, so yeah, start shell Python. I thought you could do that. Nope. Let's try this. Let's try start shell SU. Or, oh, this is SH, never mind. So we do have C, it looks like, but I'm not a C programmer, and from what I understand, C is kind of a bit of a more difficult language. So I definitely don't want to have to learn to be fluent in the C language before this test. I got enough to worry about besides that. But yeah, unfortunately, I don't think there's a way to get Python working. I could use, I think, a bash script to do that. But that would be great if I could figure out how to do that. Yeah, so can I run commands in here? Because if I could run all the help commands in here and search through all the help documentation, oh man, that would be really, really useful. So so I've clearly got like LS and those sorts of things that I would have in a regular Linux bash shell. But I wonder if there's a way I can run a regular command. Yeah, like, oh yeah, okay, so I can use this CLI here. So, okay, so CLI. There we go. So I can defer up to the CLI. And then here I can use for loops, while loops. So I can do, I can save output to a variable. So what I can do is CLI help so let me just look at the exact command I used before. Oops, and it looks like my buffer doesn't go back that far. Either that or it was on a different device, so I don't remember. Oh, okay. It looks like I am getting the routes here. So that xstart, show OSPF neighbor. Yeah, that xstart was just on its way to full. It just took it a while to get there. So, but this is a really, I think, great thing I could learn is to do the start shell and then do CLI. Let's see if I can figure out what other commands I get besides CLI, but yeah, to use that CLI to run a command, save it to a variable, and then search, and then use for and while loops to search the help documentation and bring me back something I might need. So for example, if I want to learn more about xstart on the fly during the exam, I just save all the documentation and then go through xstart, and then it will spit back the any documentation that has xstart in it, and then I can read all about it right there during the exam. So CLI. Oops. Okay, so it looks like I can't have a space. So let's do here help doc equals CLI help topic OSPF. Okay, CLI command not found. So yeah, I'm not sure what's going on here. Looks like my brilliant idea of being able to do this either isn't going to work at all or isn't going to work the way I had hoped it would. So yeah, it looks like it's just not going to be something that will work. But that would be a really, I think, neat kind of advantage during the test to be able to just pour through all of the help documentation instantly. And if I have a question about something like xstart, like, oh, why is that stuck in xstart again? Instead of having to memorize, so much information, like it gets to the point when you're studying for your CCIE or your JNCI ESP, where it's like, if I really need to know something, like, I don't know if like studying is an effective strategy, because I just need to know so much information that really a more effective strategy than studying and memorizing that information is going to be to instantaneously be able to conjure it up when I need it. Especially since, that's not even the answer. Once you have it memorized, that's just one variant of the answer. Okay, so show configuration. Okay, but we've got our topology set up. Everything's good. We can ping end to end. So let's do an example of OAM, and then we'll leave it at that. In fact, there might even be a just an example that they have here. So this is Ethernet interfaces. So let's go to the OAM section, operation, administration, and management for Ethernet interfaces. Yeah, there might even just be a good lab that we can do here. And I guess I'd rather just do one of the labs they have than kind of just wing it on my own. So yeah, there's all kinds of examples here. So configuring CFM on physical interfaces. Aha, here's a perfect point-to-point example that looks really straightforward and nice. Then we've got CFM on bridge connections, CFM over VPLS. I'm kind of tempted to do all three of these actually. I might want to do another video because all of these are going to be, I think, kind of essential. And not just on the test too, in the real world. It's like, oh, I wish I had known about this documentation some days when I was on the job. All right. So that looks good. So let's try to pick out some more here. So we've got 802.3 OAM. So link fault management, that's probably more what they're getting at. Ethernet link fault management for CCC. Yeah, I think this one's going to be probably a good one to go over. Here we go. So I think this is exactly, yep, including fault detection. So I think this is exactly what they're saying to go over. So you know what? I'm going to skim the fat. And this really looks like what is going to be on there. This link fault detection. So I'm gonna stick to my word. I'm going to just do this one exercise because I think this is what it's going to be. And then I'm going to move on to the next topic. Before I do that though, I will get some more water and be right back. All right, so now I will finish up this example and then move on to the next topic. So this is going to be a 3-router topology. Looks like a really good example of a service provider network. So I'm kind of excited for this one. It looks really relevant to this exam. Oh, and actually that was the other one. I suppose I could do that one as well, but I guess I'd rather just do as little as possible because I've got a lot more to cover. And as I learned from my calculations, at my current rate, I'd have to spend about 4 hours a day of study to get through it all. So let's not give any one topic too much time. Okay, so I will delete router 3 since it's not going to be needed. And then we're going to have AE0. Yep, we've already got that set up. So in this example, LFM is configured on an aggregated Ethernet interface, AE0, between router 1 and router 2. When configured on aggregated Ethernet, LFM runs on all the individual member links. LFM is enabled or disabled on the member links as they are added or deleted from the aggregation group. The status of individual links is used to determine the status of the aggregated interface. Perfect. So to configure LFM on an aggregated interface between the 2 routers, configure LFM on router 1 for AE0. So let's do that. Go on router 1. Yep, and we already did all this. I've got a really good understanding of how that works. So configuring link fault management, really easy. Perfect, so really easy. So now let's look at router 2. Yep, same deal, same commands. So yeah, this might be a little bit too stripped down. Like I'm sure there's gonna be a lot more. What I'm gonna do now though is do set protocols OAM and just look at some of the extra options. So we've got options for Ethernet or options for a GRE tunnel. For Ethernet, we've got link fault management, we've got LMI, Ethernet local management interface, we've got FNP, failure notification protocol configuration, and we've got EVCS, Ethernet virtual circuits configuration. What I have a lot of real world experience with is connectivity fault management, CFM. So these are configurations related to the 802.1ac Ethernet OAM. But let's do link fault management. And under here, we've got options for the interface. That's really the only option. We also got action profile. It looks, I'm kind of surprised we don't set up action profile, but let's just follow the example exactly as is. Hopefully there's some verification steps. There are no verification steps. Oh, okay, because we're not done yet. We got to do the action profile. That is a required step. You can create an action profile to define event fault flags and thresholds for the action to be taken. You can apply the action profile to one or more interfaces to configure an action profile. So we're going to detect a fault with this. So, aha, here we go, link down. So that's going to be our action. Configure private, edit protocols, OAM, Ethernet, link fault management, edit action profile, and it's going to fall in line with the name of our topic here, and that's fault detection. So we'll name it fault detection. All right, perfect. So now we're going to specify the action, and it's meant for fault detection. So we're going to detect a fault with the link. So okay, well, this is the action we can take. So we wanna detect a fault with the link. So the actions, let's get some help on action. So action to take on specified events. So this is kind of backwards. Like it looks like it's just in plain old alphabetical order. It's not in an order that makes more logical sense to how the action profile is actually put into effect. What it does is it looks for these events. So I snap my fingers. I want you to twirl around in a circle. So you've got a list of things that can happen. Slap your fingers, clap your hands, cross your fingers, and then you've got a list of actions, twirl in a circle, jump up and down, that sort of thing. So these are the things you can do to the signals. And then here's all the signals, the events. So let's define the events first and then the action second so that it's more, I think, logical. So this is going to be fault detection. So yep, let's see if the protocol goes down. Let's see here. So let's just set up, yeah, link adjacency loss. Yeah, let's just go with that. Yeah, and this is where it gets neat for service providers, because you can take actions based on the amount of frame loss, based on really extensible, specific things happening to over your links and to your traffic. Really valuable thing to be really comfortable and a master with. If you can learn this stuff and put this on your resume, I guarantee you can get hired at a service provider, possibly overnight, because they are really, really serious about this sort of thing, because they have an obligation to the customer to prove that they're providing the service they're providing. And that requires, of course, configuring this kind of configuration, which can get very, very complicated. And not only that, this is the kind of thing, I mean, have you heard of OAM? Like who has heard of OAM? Like even in very specific niche circles of network engineering, it's still niche. Like there's not a lot of network engineers who are true experts in OAM. Wasn't a part of the JNCI PSP, certainly not going to be a part of anything below that. Really, the only time you're going to learn about OAM is for service provider expert level exams. So really, really niche topic, really few people working on that. So even if you're just a beginner and you want to work for an ISP, I would actually recommend somebody watching this channel learn a lot about OAM. Just do a few weeks of self-study on that. Put it on your resume. I'm sure that will probably trigger some some flags on like automatic recruiting things if you want to work in for a service provider, which I did for 5 years. So there you go. All right, so let's see what, so let's see what happens if I commit this. Okay, so it looks like they are giving us things to actually put in. So yeah, specifying actions. So yep. Oh, I don't think we did that yet. Actually, we're still doing events. Yeah, so the event is, yeah, so let's just follow what they've got. So set event protocol down, they have that event as well. So now they're going to be setting actions. Perfect. All right, so looks like we've got a few more commands that they're setting in there. All right, so I think everything's good to go. So we got to apply the action profile. Okay, so everything committed properly. Let's set it up on the other side. Oh no. Oh, okay. A car, I have my parking space is here. My neighbor's parking space is here. I heard a large popping sound, and I noticed my neighbor was here right behind my car, and I was like, they must have hit my car. But there's a bunch of balloons outside for some reason. I saw a bunch of balloons out there, so I saw a balloon right by their wheel that looked like it had been popped. So I think the balloon just got run over and popped. That was kind of a nightmare though for a minute. All right, so let's see here. We're going to be, display set. We're going to be looking at the configuration here and applying it to the other side as well. So this is action syslog. Yep, so we're going to be starting here. Perfect. Now, I'll look at that configuration again, and you can see, of course, as I said, this is really messy, long config, so it's running off the screen. Even if I expand it out, it's going to go nearly all the way to the end. It's almost as long as a command containing a full SHA encrypted hash. So this obviously gets very, very tricky config. It's kind of not fun once you get into the weeds with OAM. But hopefully we will be able to see link adjacency loss, and when I do a monitor start messages, I'll get a message showing up there due to OAM. So now that the state is going to change, hopefully I'll get a syslog message. And syslog messages, I believe, show up in the messages. Let's do a files or show log messages. Might need to set up logging, syslogging. I know in Cisco you do need to sometimes enable logging, especially if you're on through like a SSH session on Cisco, you have to do terminal monitor. But console usually just does it automatically. I'm not sure if it's different on Cisco's. Okay, so that looks more promising. I'm setting up for the syslog to be sent to the console, which is what I'm in now. So let's roll back that change. And I think it'll trigger for the interface going up as well. But I guess it would make sense if it didn't, because the name of the command was the link going down. So let's try it with the link going down. Oops, and we're still not getting a syslog, even though I've got the command in there now. Yeah, so I guess I'm not sure why the syslog message is not showing up. Let's do a Google search. All right, so I think I'm gonna have to walk away a little bit unsatisfied. Unfortunately, there's just too much on the exam to really go too far into depth on something. I kind of have to touch everything, and it's kind of like how I like to handle a all-you-can-eat buffet. I like to have the first plate of trying a little bit of every single thing, and then going in and the thing I like best, loading up on that. So I want to be able to be sure that I've practiced every part of the test, and then any part I feel I need a lot more practice on, I'll get time to go back to later. So if I'm spending too much time on any particular part, I'm not going to get to the other parts. So this is going to be the last video. Unfortunately, I think it was pretty unsatisfactory. I was able to get a lot of practice setting up aggregate Ethernet interfaces, but that's really not that difficult. I didn't get that much practice with OAM. I tried to set up fault detection, but I had trouble doing that too. I'm hoping that my real world experience will kind of bail me out. I've had a lot of experience setting up maps and MIPS, MPIDs, that sort of thing. So if that's on there, I'm hoping that I'll be prepared enough through my real world experience. And I don't think it's a good strategy to spend a lot of extra time in the lab on something that I've spent time on in the real world. So with that, I'm gonna end it here. Unfortunately, I did not get, I think, a satisfactory lesson or practice, but I can't spend all my time on this one topic. So I'll see you in the next video where I go on to the next topic. Why don't I go ahead while we're still here and just mark this off and take a look at what's coming next. So I'm going to change this to done. All right, so the next video will be graceful restart. See you there.